Okay. 11.1, number 11. The first thing I had to do was complete this following chart. And basically what this chart is showing you is, what this chart is showing you is when you add an even number plus an even number, your result's going to be even. When you add the sum of an even number and an odd number is going to be odd. Odd plus even, odd plus odd equals even. But when you multiply, it's going to be, when you multiply an even number times an even number, the product's going to be even. When you multiply an even number times an odd number, the product's going to be even. Odd times even is even. Odd times odd is odd. So that was the first thing I had to do, was complete the chart. Then after that, it wanted to know if I could make any kind of conclusions about the sum of even numbers. So what I did was give you guys a few examples before we made our conclusion, and I just picked random whole even numbers. So I went 2 plus 4 is 6. So when I added these two even numbers, it gave me an even answer. So then I tried it with 3 different even numbers. I went 2 plus 4 plus 6 is 12, and the result was still even. And as you can see down here, I used more examples of adding even numbers, and I concluded that the sum of even numbers produces even numbers. And then we basically had to do the same thing for letter B, but it wanted to know using odd numbers. And you said you can use any amount of odd numbers. So when I added these two odd numbers together, 3 plus 3, I got an even answer. So it would be real easy to conclude right now that this can give you even answers. But if you see right here, if you add 3 different odd numbers together, 3 plus 1 plus 5, I got 9. So I got, my result here was an odd number. So I used another example, and what I concluded was when adding an even number of odd numbers, the sum will be even. But when adding an odd amount of odd numbers, the sum will be even. For letter C, it wanted to know the product of any number of even numbers. So we know, we see the word product, so we know we're going to have to multiply. And what I did here was, we had, I chose random numbers. I chose my even numbers. 2 times 4 gave me an even answer. So then I chose 3 of them, 3 different even numbers. 2 times 6 times 4 is 36. Gave me another even answer. I chose another one, just random numbers that were even. And in every case, it gave me even answers. So I concluded that the product of any number of even numbers gives you an even answer. Then I had to do the same thing for letter D using odd numbers. I just chose random odd numbers. 3 times 3 is 9. 2 just odd numbers equals an odd number. There I chose 3. I went 3 times 1 times 5. Still, my result was still odd. And there's another scenario, odd, odd. So I was able to conclude that the product of odd whole numbers gives you odd answers. In E and F, I was able to kind of combine. It wanted to know, for E, it says whether it's possible for an odd number to have an even factor, and whether it is possible for an even number to have an odd factor. So right here, I just chose random numbers. There's 9, which is my odd, and I multiplied it by 2, which is my even, and it gave me an even answer. So you see that my odd factor times my even factor gave me an even multiple. And then 6 times 2 times 3, 6 times 2 times 3 is 36, and you see right here where I used an odd factor times an even factor times an odd factor gave me an even multiple. So no, odd numbers don't have even factors, but even numbers can have odd factors. And those are the examples that I gave to make that conclusion. I had to actually, for letter G, I had to Google what a closed number or a closed set was, because I actually had no idea what that was. And what I found was, under addition, when you're adding these two numbers, 2 plus 4, both of these are even, and it gives you an even answer. It means that this is a closed set, because every number in this group is even. So is the set of even numbers closed under addition? And the answer is yes. And I just gave you 2 examples. 6 plus 8 is 14. Even plus even is 14. So this is a closed set. And then when I did it for odd, you see I used 2 odd numbers. I went 3 plus 5 equals 8. And 8 is an even number, so the answer for H is no. that under addition, odd numbers are not closed. And then I had to do the same thing for multiplication. And right here was 2 times 4 equals 8. So 2 is my even number and 4 is my even number. When I multiplied it, it gave me an even number. So this is a closed set. Here's another scenario of multiplying 2 even numbers to get an even number. And there's a third example. So yes, this set is closed. Is the set of even numbers closed under multiplication? Yes. And then for the last one, it wanted to know odd numbers. So it says, is the set of odd numbers closed under multiplication? 3 is odd times 5, which is another odd number, equals 15. So 3 times 5 is 15. All odd, it's a closed set. There's another example, and there's another example. 5 times 9 is 45. So yes, the set of odd numbers are closed under multiplication. Thank you.
Thumbs up.